Hi guys, today we're going to be doing basic arithmetic and algebra, and we're going to be focusing on a specific exam preparation paper. Okay, so it's the first paper for this topic, and I'm going to introduce these questions in different difficulty levels. So depending on what you think is easy and what you think is hard, you can skip your way through to the questions that you need, or start from scratch and trying to go from the basics to the hardest. Okay, so let's get started. I'm going to start with part 1, which has a difficulty level of 1. So it's actually the easiest level in an exam. So these questions are going to be very minimal mark questions, so maybe 1 or 2 mark questions. So make sure you know these part very, very well because it is the basic level. Okay, so let's get started. I'm going to start with question 1. It says, change 0.2 to a fraction. And you see the dot out the front, on the top, sorry? It represents a recurring decimal, okay? So you should know that it is a key skill to have only the decimal digits repeated. So this just means that the numbers in front of the decimal, after the decimal, with the dot on top, are the only ones that are recurring, nothing else. So in this case, only the 2 is recurring. So it's 0.22222, but you should already know this very, very well. So to start off this question, what I'm going to do is let x be 0.2 with the dot on top. Okay, so x is going to be 0.22222. Okay, so I'll just let that be my first equation. Now, what I'm going to do next to solve this question is multiply some numbers of 10 to this equation 1. So what I mean is I'm going to multiply both sides by 10. Okay, so this will become 10x, and this one, all I need to do when I'm multiplying by 10 is move the decimal 1 position, okay, 1 position to the right. So I have 2.22222. Okay, this is just some obvious stuff, but I'm just going to show you that I'm multiplying by 10. So now what can you see? Can you compare these two equations? Okay, I just labeled it equation 2, and this is equation 1. Can you compare those two? And can you see that after the decimal point, they both have 22222. That's common, isn't it? So if I subtract 1, the first equation, from the second equation, can you think that the 2's will eliminate? So like this. So if I do this, so equation 2 minus equation 1, so I'm multiplying 10x minus x on this side, and 2.2222 minus 0.2222 on this right side. Okay, and as I said, the 2's after the decimal point will eliminate. Okay, so you can see that all of these 2, they will just eliminate because they're subtracted away. So now all I need to do is 2 minus 0, which is 2, and 10x minus x is 9x. Okay, so that's what I did. And you can see all the recurring decimals have gone away. Okay, so I don't have to worry about those anymore. So it's nice and simple now. And you can just calculate that and solve for x. X is just 2 on 9, isn't it? It's a very simple step there. Okay, so the point of multiplying by 10 there was trying to eliminate away the recurring decimal. Okay, so that's the main point there. That's basically the key to this question. So now that I've got x, it's a good idea. Some of you will think that we've actually finished the question, but it's a very good idea, well, if you do have the time, to check using the calculator. So put in your calculator 2 over 9 and just change it to a decimal, and you'll be able to see that it's 0.22222. So this is a way to check your answer. Okay, and if you see in your calculator you don't have this value here, that means you've done something wrong and that's not the answer. So as long as you get this in your calculator, that means you've got the correct answer and you can ensure that you're going to get full marks for this question. Okay, so it's really a good question actually because you can check your answer. So we know that that's the case, so therefore x, or our recurring decimal 0.22222, is in fraction form 2 over 9. Okay, so that's pretty much it. So hopefully that wasn't too bad. Okay, that's a very typical exam type question, so you make sure you know this very well. Okay, it's very likely to come out in your exam. Now question 2, we've got a similar question. It says change 0.32 to a fraction, and you see that this decimal also has some dots out on the top of the numbers. And this time you can realize that it's different to the previous question because it has two points, two dots on top of the two numbers. So 3 and 2 are both recurring. Okay, so it's going to look like this. Well, I'm going to let 0.32 with the dots on top be x like we did for the previous question. And you should know that this is 0.323232 recurring on and on infinitely. Okay, so this recurring stuff, it should be all clear to you. So I've let that be that. So x is going to be 0.323232 as I said, and I'm going to label that 1 like we did in the previous question, so just so I can refer to it. Now, again, we have to do the same thing, multiply values of 10 to it. So when I mean by values of 10, it could be 10, it could be 100, it could be 1,000, depending on the question. So it's not, you don't always multiply by 10, just remember that. So in this case, what should I multiply by? To make sure our main goal is to eliminate out all the recurring numbers, okay, just to make our equation much more easier to solve. This time, hope some of you can actually tell me, but this time I'm going to be multiplying by 100 on both sides because, well, first of all, x times 100 is 100x. Make sure you're doing it to both sides. And 0.323232 times 100, you move your decimal 2 places to the right, so I have 32.32323232. Now, I hope a lot of you can realize why I've multiplied by 100. See how these two, after multiplying by 100, after the decimal point, both equations have 323232 after the decimal point, which is exactly the same for both, isn't it? In that way I can eliminate it. So I'm going to subtract it again. So I'm going to subtract equation 1 from equation 2. So I have something like this. On this side, on the left-hand side, I'll have 100x minus x. And on your right-hand side, I'll have 32.323232 minus 0.323232. And you can see that all of this part after the decimal point is exactly the same. They will be eliminated. So my equation will simplify to 100x minus x, which is 99x, and 32 minus 0 is just 32. So nice and simple again after I've eliminated all the recurring decimals. So all you need to do now, guys, is solve for x. X is going to be 32 on 99. Okay, so we've basically got the answer, but make sure, guys, you're checking your answer in your calculator. It only requires a few seconds. So just put it in your calculator, just double check to ensure that you've got your answer. And you can summarize or conclude by saying your recurring decimal is changed to a fraction form of 32 over 99. Okay, so make sure you check. It just takes a few seconds, so you might as well do it just to ensure you're getting full marks for this question. Okay, so the only difference here was that I'm multiplying by 100 instead of 10. Okay, and that's usually the case when you have 2 recurring decimals. Okay, so hopefully that's pretty easy as well. Question 3. Convert 38% to a fraction in its simplest form. Okay, very simple question. So 38% is 38 over 100. Okay, so you should all know this. 38% is 38 over 100. Percentage means it goes over 100. So now all I need to simplify. I think the common factor for 38 and 100 is 2. So I'll divide top and bottom by 2. So 38 divided by 2 is 19, 100 divided by 2 is 50. So, and there's no more other factors. 19 is a prime number, so I can't go any further. And that's your answer. How simple is that? 19 over 50. Okay, and probably this is just like a 1-mark question. Okay, very, very simple. Now question 4, convert 6.25% to a fraction in its simplest form. Well, again, 6.25% as a fraction is 6.25 over 100, isn't it? So make sure you change it like this first. And then I'm going to show you that it simplifies to 1 on 16. Well, this is pretty simple, I guess. But if you guys like to do it by hand, step by step, from this step, you can. Because I don't like having decimals inside a fraction, I'm going to try to get rid of that decimal by multiplying this by 100. If I multiply that by 100, the decimal place will move over to the right by 2 places, so I can eliminate that decimal. But if you're doing that, make sure you're doing it to the bottom as well. So 6.25 times 100 is 625, and 100 times 100 is 10,000. Right? And then just work your way through. So if you can't really find the highest common factor straight away, just divide the top and bottom by 5 first, because I can see immediately that 5 is a common factor. So you divide top and bottom by 5. If you see any more common factors, divide by that. So you can require a few steps if you need to, okay? So don't hesitate to do that. So I've trained it like this first, and then just cut it down by any factors you see. Okay, but if you can, it's a good idea to if you can change it to 1/16 straight away, or you can probably just use your calculator and stick in 625, or even stick this fraction in the calculator straight away, and you'll just be able to convert it with your calculator. So keep that calculator in handy. Okay, so same for both questions. If you can use your fraction key, you can change both of these in your calculator. So just practice doing that in your calculator. Okay, so these are two very, very simple questions. Let's move on. Question 5, convert 0.1% to a fraction in its simplest form. So again, very same question. 0.1% is 0.1 over 100. Okay, and that will be simplified to 1 over 1,000. Now again, this one you can put it in your calculator, but I think most of you can just do this without using a calculator, because as I said, I don't like having decimals inside my fraction. So to eliminate that decimal, I will multiply top and bottom by just 10. So the top, 0.1 times 10 is 1, and 100 times 10, you just add an extra 0, making it 1,000, which is the same as that, right? So just multiply top and bottom by 10 will get you to the answer straight away. Very, very simple again. Question 6. Express 300 million in scientific notation. Now you should all know that scientific notation is when I'm multiplying a number by 10 to the power of something. Okay? When the number gets too big, too massive, then I'd like to use scientific notation. Or vice versa, if the number is too small and there's so many decimal places, I like to use scientific notation. Okay, so this number is quite large, that's why I want to change it to scientific notation. Now with scientific notation, you always want to have your decimal in front of your first number. Okay, but in this case, I can just make it to 3 times 10 to the power of 8. Okay, because all the following numbers are 0, I don't have to worry about any decimal points. It's just 3, and how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8. So it's just 3 times 10 to the power of 8. So that's much more simple than writing out all those zeros like that. Okay, so scientific notation is just a simple way of writing, just so you don't have to write so many numbers. Okay, so make sure that you know the use of that first. That's question 6. Question 7. Express this number, I don't want to read that out, in scientific notation. Okay, so it's again a very massive number, and I want to change that to scientific notation just so it looks more simple and more easier to refer to. Now, as I said, I like to have my decimal in front of the first number. Okay, because a number like this, when it's not all 0, I like to have a decimal in front of the first number 7. So I have 7.6 times. If I put the decimal there, how many places of 10 do I have to move to the right by to go back to the original spot? Well, from here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so 11 decimal place to the right, I need to go from that point there. So 7.6, so put your decimal point after the 7, and then we're going to times that by 10 to the power of 11. Because remember, as I counted, it's 11 places to the right. And that's it. And it's a good idea, guys, is to put, I rounded off to 1 decimal place. Okay, so because I don't want to go ahead and write all those decimal places out, because that means there's no point of having it in scientific notation. So round it up to whatever you want. If it doesn't specify, just round it to 1 decimal place and just write at the end 1 dp. Okay, and it's a good idea to just tell your teacher that you've rounded it off to 1 dp. Okay, or decimal place, sorry. Alright, so that's the answer to this question. Have a look. Okay, so that's question 7. Now question 8. Evaluate this whole fraction in scientific notation correcting to 3 significant figures. Guys, I want you to just pause for a sec and put that in your calculator and see what you get. This question, you should use your calculator. So put that in just nice and carefully and see what your outcome is, and then check with my answer. Okay? So put that in and you should get something like this, 0.0795 blah blah blah. Okay? So just check. If you haven't got that, you've probably did something wrong. So make sure you practice doing that in your calculator. And I want to round it to 3 significant figures. So remember, 3 significant figures is not decimal places. Make sure you know the difference first. Now, significant figure starts from the first non-zero, okay? The first number that's not 0 is 7, so I start from there. So I say 3 significant, so I go 1, 2, 3. And the number after that is 1, so I don't have to round 5 up. So it's simply going to be 7.95, and see I put the decimal in front of the first number, but when I mean the first number, it must be the first number that's not 0. So in this case, the number that's not 0 and it's first is 7. So I'm going to put the decimal there, just like I did here in the answer, and I'm going to see how many decimal points I have to move to go back to the original spot. The original spot is there, so I move this time from here, I move backwards 2 places. Because I'm moving backwards, which means it's to the left, I have to stick the -2 on top. Okay, so it's not going to be 10 to the power of +2, it's going to be 10 to the power of -2. So that's your answer. And I've rounded it off to 3 significant figures. Okay, so have a look there. Maybe this was a little bit more challenging than the first one. Okay, does that make sense, guys? So have a look at that. So there's 2 requirements here. You first need to change it to 3 significant figures and then convert it to scientific notation. Okay, so there's 2 little steps there. That's question 8. Question 9, simplify square root of 75. So this doesn't mean to calculate using your calculator, it means to simplify the surd. So it must be still in exact values, okay? So you know that 75 is 5 squared times 3, because 5 squared is 25. 25 times 3 makes 75. And you should know that I'm doing this because I want to have a square number so I can pop it outside. So I know that 5 squared, 25 is a square number. So I made it into 5 squared. So you should know that the 5 can pop outside like this. Okay, so it's 5 and the odd one just stays inside the square root 3. Okay, or there's many ways to do this question, guys. There's many ways to view it. So this part here, you can separate the surd like that if you like. Okay, if it's too confusing to go from there straight over there, divide it like that, so like separate it out. And you should know that 5 squared is 25, square root of 25 is 5, or you should know that the square root and the square always cancels itself out. So the answer is just 5, and then times the root 3, we have root 3. Okay? Or, I know some of you like using the tree method. I'll show you how to use the tree. If you can't think of any square numbers that multiply to 75 straight away, it won't take straight away, but if it's hard for you to do that, use the tree method. So put 75 at the top, draw 2 branches, and my aim is to keep the prime factors of 75 down my left hand side. So I can immediately see that 75 is a multiple of 5. So if I put your prime factor down there, okay, and then you go 75 divided by 5 is, it's going to be 15. Okay, 5 times 15 makes 75. Now have a look at 15. 15, I can divide that by 5 again, and then 5 times what is 15? 3. And that's it. So I can't go any further. These are all prime numbers, so I can't go any further. So now have a look at all your numbers on your left-hand side. Don't worry about 15. We're only going to look at the numbers on your left. And then you can see that 5 and 5 are a couple. So look for couples. 5 and 5 are a couple, so circle them. So you put the 5 outside, and the odd one, which is a 3, goes back inside. And that's how I do it, okay? And then that gets the answer straight away as well, 5√3. If you don't really understand why that's the case, have a look, guys. 75 is basically 5 times 5 times 3, okay? So the point of this is trying to break it down into prime factors. 5 times 5 times 3 is the square root of 75. So to get the square root of 75, you simply square root it. And as you can see, we got the same thing as over here. 5 times 5 is 5 squared, which becomes square root of 5 times 5 is 5. Okay, so sorry the explanation was quite long for this question, but I just wanted to show you that there's lots of different ways to approach this one. So think about which way is most suitable for you, and then trying to use that in your exam. Okay, that's question 9. Question 10. Evaluate this number here, corrected 2 significant figures. So again, guys, you just need to use your calculator. Simply insert that in, just do it very carefully. So again, pause for a sec, put that in your calculator and check if you get the same answer as me. Okay, so go ahead and you should get something like this, 3.68508, etc. So you're going to get a long number, but we want to correct it to 2 significant figures. So 2 significant figures is starting from the very first number. We know that that's not 0, so we can start from 3. So it's 1, 2. And as you can see, the next number here, 8, is larger than 5. So I must round 6 up to 3.7. And that's your answer. Okay? So again, this is just a simple 1-mark question. So make sure you get this definitely correct in your exam. Okay? So that was part 1, guys.